Hey guys, we're going to focus on irrational and rational numbers and talk about the differences between them and how to find them, which one's which using a calculator. So there's a little background about types of rational numbers in the box. So you can see one talks about rational numbers and it gives you some examples of rational numbers. And then irrational numbers are something that tend to have non-terminating and non-repeating decimal representation. So you'll see a bunch of numbers, really no pattern will emerge. So we're going to look at a few of the examples and the exercises, kind of get us going. So for exercise 1, they give us a rational number and a non-rational number. Now one of the things about rational numbers is you should be able to create a representation of it. So if you're talking about like half a pizza, in the case of a pictorial representation of 2/3, well, you could break this into 3 parts, and then you would just fill in 2 of those parts. So that would be a representation of 2/3. It also says for part B to use the calculator to do a decimal representation, which would be 2 divided by 3. So you end up getting 0.666 repeating. But you'll notice that the 6's repeat, and sometimes you might see 0.6 with a bar over it as well. Now, here's the thing. If you take something like C, where it's asking for the square root, so we'll do second square button, and then we want to do a fraction, so 1/2, and then hit enter. What you're going to see is like it says to write all the decimal places, we got something that really has no defined pattern. So we see a few 7s, but they're not consistent. Same thing with a couple 0s and 1s, but there's no pattern to it. And in the case of D, well, it says, why can you not draw a pictorial representation of the square root of 1/2? Because, again, there's no exact amount. We could give an estimation of it, but in the case of 0.7071 and going on, the numbers are going to keep coming out, and it's going to give us something that isn't going to be exact that we could represent on, like we did for part A. So that's the big thing with rational and irrational. Rationals repeat and can be written as fractions, and irrationals don't repeat, and they have no fraction equivalent. So if I tried to change that back to a fraction, by hitting math and fraction, I'm going to get a decimal again, which means that it can't be written as a fraction. So let's move on to exercise 2. And again, I'm just going to do the first one. Write out every decimal your calculator gives you for these irrational numbers. So I'm just going to do the first one right now. I'm going to do the square root of 2. There are a lot of square roots that are irrational, but there are some square roots that are whole numbers, so you got to keep that in mind. So like this one right here is a square root of 2, which is 1.414213562. So again, no pattern. But like I said, remember there are square roots that are whole numbers. So if you take like something like the square root of 9, which I know isn't on the page, that ends up being a whole number. So you got to keep that in mind. Not every single square root is going to give you an irrational number. So going on to exercise 3. Now, if it is an irrational number, and we'll do a little bit of this for exercise 3, it does have a place on the number line. So like it says, without using your calculator, between what 2 integers will this number lie? Well, there are 2 square roots, 25 and 36, which end up equaling 5 and 6. So for that reason, the square root of 28, or radical 28, will be between 5 and 6. Now for part E, they want us to use the calculator. Okay, so you can kind of see what we just talked about. It's between 5 and 6, so it's 5.2915022622. So again, you can make predictions as to where they're going to fall. Sometimes that can be helpful because you might see something maybe where you have to graph that might have a square root in it. And you'll see in the case of the x and y values, you'll see a lot of decimals. Now, the last part we're going to look at together, we're going to skip over C and D, but if you go to exercise 4, so these last three we're going to look at, and it says here, for each of the following addition or subtraction problems, a rational number has been added to an irrational. So if we take like B and put that in the calculator, so if I do 4/3, and then I add the square root of 10 to that, what happens is I got 4.495610994. So you'll notice that this one, if I press some math and try to change to a fraction, won't give me a fraction. Which means that in this case, if we take a rational number and we add it to an irrational number, what we're always going to get would be an irrational number. And then for the last one, exercise 6, so exercise 6, they're asking us which of these is irrational. Now, we just talked about fractions are rational. And the rest of them contain square roots. So what you want to do is you want to go ahead and type each of them in. Now, we just did square root of 25, or radical 25, which is 5. So this one's going to be rational as well, because that's going to equal 5. And then we could do 2. If you do 4 minus radical 9, you're going to get a number 1, because the square root of 9 is 3. So this ends up being 1, which is a whole number, and rational. So that leaves us with 4, which is 3 plus radical 6, which that one gives us irrational, because in the calculator we get 5.4494897743. So the one that's irrational is going to be 4. And again, it's a rational 3 plus an irrational 6, which always gives us an irrational number. So just to recap, like we talked about, if you have a rational number, it should be able to be written as a fraction, or it could be whole numbers. And irrationals don't end and don't repeat.